Show the mechanism for the antiMarkovnikov addition of HBr to 1-propene. Antimarkovnikov means the H gets added to the carbon with less H's, and the other one gets added to the carbon with more H's. Usually it's the H gets added to the carbon with more, but this time it gets added to the carbon with less H's. So let's do this. So an example of peroxide is tert-butyl peroxide. Okay, so if you heat a peroxide molecule, what happens is half of that bond that links the two oxygens, half of it goes to that oxygen and the other half goes to the other oxygen, and you form two radicals. Okay, so now that radical will react with HBr. So one radical reacts with an HBr molecule. So that lone electron and one half of that single bond, they get together to form an alcohol, and in the process you produce the other half of that bond between the H and the Br goes with Br as a lone pair. So now you have a bromine radical. Okay, so this is step 1, this is step 2, and step 3, this is now where the alkene reacts with the bromine radical. So we have the alkene, H2, plus the bromine radical produced in step 2. Okay, so half of that bond between the two carbons meets with the lone electron on the bromine radical, and the other half of that bond goes to the other carbon, making up the double bond, and you produce this intermediate CH3, CH, and now you have a lone electron on that middle carbon and single bond. Now on that carbon to the right you now have CH2 and you now have the Br attached to it. Okay, so the lone electron is now on the middle carbon. So then step 4 is yes. Okay, so the reactant in step 4 is the product in step 3, CH2. Remember that in step oh yeah, this is what happens next. So we have now a radical, so that there reacts with another molecule of HBr. Okay, so that lone electron on the carbon meets with half of that bond between the H and the Br, and now you form your alkene, CH3, CH, CH2, Br, and in the process you form another bromine radical. And that bromine radical goes back to step 3, back to step 3, and it will react with another alkene molecule to propagate the process. And so it keeps going until there is no more alkene or until there is no more HBr left to react.